Let us start the third assignment of machine learning of LP3. So this is about building a model based on neural network. So we have to build a neural network based classifier, and this classifier is about the bank customers churning model. Means how many bank customers are left previously, and what is the prediction that the present bank customer which are there may leave or will stay with the bank. So that we have to find out by means of this neural network based classifier. So it will give us uh, output whether he may leave or may not leave for the next 6 months. So database is from Kaggle again, bank customer churn modeling database, and almost 14 distinct features such as customer ID, credit score, geography, gender, age are provided into that with 10,000 samples. So these are the tasks we have to provide. We have to do. Uh, we have to select the features. We have to normalize the training and test data. Then we have to build the model, initialize, and then we have to come evaluate it with means of accuracy or confusion matrix. So now let us begin with the uh, first the database. So it is from the Kaggle, and if you look the this is the data file churn modeling.csv which we will download, and we will see the columns into that. So those are um, customer ID, surname, credit score, geography, gender, age, tenure, balance, number of products taken from the bank, whether he has got a card, estimated salary. On the last one is a target column, whether he has exited or not. So out of that, some are features which are not much of important. For example, if whether he has got a credit card, number of products, or even geography will play a role, important role, because we may get the uh, information about from which city the customers are living or staying with us, and then depending upon the services provided in that city we can extend the products for other customers also. So this problem is mm, very much of importance in sales analysis, customer service analysis, like that. So let us start with the uh, first the theory behind it, because we are going to build a neural network. So basically a neural network is provided in Python by means of Keras libraries. So it is derived from TensorFlow. So TensorFlow is a symbolic maths library used in for building the neural networks, and it is used to understand for creating a neural networks. And Keras is based on minimal structure that provides a easy to create a deep learning model based on TensorFlow. So using Keras, we can easily define the uh, shallow network or deep neural network, which we can train, and we will get the model. So Keras is useful for a single layer neural network model or multi-layer model, and it also helps in performance evaluation of the trained models. So in any neural networks, there is one concept called as forward propagation, in which um, input values travel up to the through every node to the output, and in back propagation, the error or loss function, which is called as, is calculated based on the output expected and output achieved. And then the weights and bias are adjusted in every neural layer so that the forward propagation will achieve the minimum loss at the mm, output. And to calculate that loss function, this gradient descent theory is used. So based on the learning rate, it will calculate the next step on next weights, which should be calculated at each layer. So some of the important concept in neural network is a node or unit. So one node is shown like this. So x1, x2 are inputs, and this is the node which is based on weights and bias. And whatever the output is passed through activation function so that we will get either binary or linear output out of neural node. So this is a single node from input to output. So if you want to build the single layer neural network, you can stack such units and you can build it. For example, this is the x1, x2 are input. The hidden layer, that is middle layer, is of three layers, and the output layer is again of one neural. So here also a neural is there, and then output is derived. Error is calculated, and it is fed back to adjust the weights of neurons. And again the forward propagation starts. So one forward and neuron will form a one epoch. So that will come afterward. So if this is a one output, at the output you will find only one neuron. But if you are means if it is a binary type, 1 0 type output. So if it is more than binary, then at output layer also you will find the neuron units are stacked. For example, here it is combination of y1, y2, which will decide the class or clusters, whatever application you have developed. So it is possible to build a multi-layer neural network by stacking multiple layers of. So if you want to increase the layers, then it will become multi-layer neural networks. For example, here there are two hidden layers. One is of size 3, another one is size 5, and say output neuron to give output say 1 0 if it is a binary output. So this is the multi-layer or neural network. Such a layers we can increase. Say for example, this is layer 1, this is 2, one more 3, like that until it is a output layer. So then it is called as deep neural networks. So there are two types. One is called as sh- shallow neural network and one is deep neural networks. So in deep learning, the number of nodes at the input layer are equal to number of features of input data, and the output layer is equal to the number of dimensions of output layer. So the theory of simple neural network remains same like this, that input layer will decide how many inputs are there, depending upon your input attributes, and the output layer depends upon how many output attributes you want, how many output classes you want at the output. So so we have to adjust in Keras the hyperparameters, which includes number of layers, number of nodes at each layer, and a number of epochs to train the model, and which loss function you want to implement. So activation function or loss function is of three types. First one is called as sigmoid activation. So which is just like a binary one. One state is 0, the other state is 1. So it is a sigmoid function. Generally you will find it at the output layer. Then the next one is tanh, which is of type +1 and -1 type. So generally this is used in middle layer because it gives the balance, or it try to put the neural around 0. And last one which is generally used is RLU activation. Activation function is of this nature. Again it is of type -2 plus. So this is also good to keep the model at the 0 or 0 bias. So that's why it is written that uh, tan h is between -1 to 1, so it is used to better to use in a hidden layer, means in middle layers, and the output is taken from sigmoid functions. So this activation function we have to also select at different layers. So this thumb rule may help to select the functions, which are the hyperparameters we are going to set. So one of the concept in neural network is forward propagation. In forward propagation, at each node, its weights are adjusted. W1, W2 are for this W12, W22, and for this W13 and W12. So these parameters are adjusted along with the bias. Then in the second layer again, weights are there for all the 5. And in the output layer, there is again depending upon the input, the layer exists because there is only one neuron at the output here. So we have to adjust these weights for every epoch. So during forward propagation, whatever weights are adjusted, we go from input to output. Here the error is calculated between expected and actual, and whatever the error is there is used to adjust these weights in every layer. So back propagation does these things, that the error will get um, backward, and it is using gradient descent. So the loss function is of dy by dx type, dy by dx type. So derivative of the loss will get backward propagated. So every layer, every neuron is of xw1 plus b1. So that will adjust the weights based on w1 b1. In the next epoch, we have to adjust these weights and bias so that the z1 will get modified. The output of that node is a1 based on the activation function you have selected. So similar three inputs are there, so it is shown like this. So total number of parameters which you have to calculate at each layer are six for this model, of course. These are six weights plus three. These are 15 plus five, and these are five plus one. So many parameters we have to adjust. So this is same thing, 6 plus 15, 5 plus 3 plus, that is total 35 parameters need to be learned or adjusted for deep learning. So loss function is, it provides us a measure of how different network predict output from the real output. So difference between a actual output and expected output is called as loss function. So how you will find a loss function? So there are again a hyperparameter which we have to adjust in Keras is mean square error, mean absolute error or mean absolute percentage error, binary cross entropy and categorical class entropy if it is just two class. And adjusting the weight for reducing the loss function from uh, for predicting the real outputs with exactly with predict one is called as optimization process. Optimization process is forward propagation plus backward propagation plus loss function gradient. Those many calculations take place in every point. So gradient descent learning is like this, that the loss function gradient is adjusted. We slowly move towards optimum parameter value. Here the way this process of coming from random value to the exact function is called as learning. So all the weights and biases are adjusted or learned so that optimum parameters will get calculated and error loss function will be minimum, which is the difference between expected and mm, actual value, actual output. So in this also we have to adjust the learning rate, the rate with which this gradient descent is falling. So that is the called as learning rate, and that is the alpha parameter we have to adjust. So generally a gradient descent works like this. We have to initialize the weight and bias arbitrarily. Then we will compute the loss for given W and weight. Then we'll get derivative of that loss respect to W and B means bias. And using back propagation we will adjust all the weights. W is equal to present new W is equal to present W minus training rate into derivative of loss. Similarly, new Bx is equal to present B minus dB. So like that, the new values of weights and bias will get calculated, which will get participate in the next calculation during the forward propagation. So that means again two more hyperparameters we have to select. Those are called as batch size and epoch. So epoch is the number of cycles, how many times the optimization algorithm should pass from forward to backward. So maybe the learning will not reach to the optimum point, and then it will become infinite loop because it is iterative loop. So we have to adjust the limit on which how many times optimization will take place. The batch size means how many attributes you uh, need to find the error. So that is called as the batch size. So number of data examples to be included each iteration for the optimization calculated. So those many iteration will get increased if you increase the batch size. You can evaluate the model by means of different metrics so that underfitting and overfitting will be uh, avoided. So this is the one where a loss function of training and testings are plotted. When they are minimum, it is called a right fit of parameters. Otherwise, overfitting will take place or underfitting of the model may take place. If you select number of epoch, how much any you should select, so that is decided by the these functions. At the minimum point, you can adjust the training rate and number of epoch so that you can stop it early. So these are the concept, these are the parameter, hyperparameter we have to adjust during the programming. So same word will come in during the mm, programming of the model. So again we will go to Colab and here it is NumPy. Our standard libraries we are included for calculation, NumPy, then Pandas, then Maths, Matplotlib for plotting, and Seaborn for the graphs. Then you can upload the file using upload function, and then you can import the file, which is our database, that is churning model.csv. It has got what 10,000 tuples with 14 attributes. Some of the attributes are not important, so during pre-processing we will drop them. For example, customer ID, row number, surname will not affect the uh, target. So those will get reduced. So number of columns will come to 11. So whether it has got a null value, that we will select. So in the database, df is an sum. There is no null value. So how many uh, attributes we are selected? Credit score, geography of the customer, gender of the customer, age, tenure, how much balance it keeps, number of products selected, whether it has got a credit card, whether it is active member, salary, and those are the parameters we will take to find whether he will exit or not. Now come to geography. Geography is column where different names are used. France, Spain, Germany. So we want to know whether which customers from which area are living or staying with the bank. So we have to again apply one hot encoding where this column geography will get converted into three more column where it will say whether the attribute exit or not, means whether it is from France it will become one, otherwise in all other it will be zero. So if you apply that, this type of things will come. For example, three more columns are added, that is geography France, geography Germany, and geography Spain, and the values are 1 if it is present, 0 in that column, means this is Germany, this is France, and this is Spain. So it is like this, and if it's from Spain, then like this, remaining columns will become 0. So this is one hot encoding used for uh, geography. Then gender also has got male female, so you can make it 1 and 0. So that type of encoding is you applied. So female and male words will be replaced by 1 and 0. And then we'll check the output. Means if exited it is 1 and for not exited it is 0. What is important is that it is 7,900 are staying with bank and 2,000 that exists. So it is the imbalance exists in the database. So probably it may affect the output also. Balanced database gives the correct modeling parameters. That is one of the criteria. So what we'll do, we'll drop it from the main table and we'll create a new exited column. Then we will apply trend test split. So again we will take 80% uh, training and 20% testing out of those 10,000 samples in the main database. Then all the columns will bring to standard scaler because they are in different units. So standard scale we will apply for X train and X test. Now here we will import the keras from TensorFlow, which will help us to create the sequential model of neural network. So now if you look the model declaration, you will find we have declared three layers. One input layer that is of 12 attributes. Activation function we have defined. Then middle layer is of 15 nodes. Activation again RLU. And the Keras output layer is just of one because whether customer leaves or stays that we want to know. So output layer is just one with activation is sigmoid because sigmoid is from 0 to 1. So that way you can define the model, you can adjust the hyper models. And then for calculation of the loss function, again you have to adjust some uh, parameters. So we have selected loss function is binary cross entropy as it is a output is binary. Matrix is accuracy and optimizer is add. So this is for the loss function or for back propagation. Once it is done, you can put model for fitting based on X train and Y train. And here I have not defined batch, but I have put a limit on number of epochs that is 100. So within 100, the model should learn for this application. So if you look here, it is a number of epoch out of 100, 45, 46 like that. So finally it will go to 100 where loss function is 0.31 and accuracy is 0.86. So with 100 steps we have reached to 86% accuracy in the model training. We can evaluate that model. The 86% is accuracy. With that model we will proceed. If you want to this accuracy is affected by the balancing in the database as well as the number of epoch and the parameters you have selected. Then we will go to Y predict means we will train it for X test also, and from X test we'll get Y test, but it is a continuous value, so we have to convert it into the binary by means of this. Y predict is if it is zero point 0.5 more than zero point 0.5 it is 1 and 0 like that, and then we can apply the classification report. What is the precision, what is the recall, what is the F1 score and support. So there are more values of 0, so support is more for 0 and less for 1. Accuracy as I told you it comes 0.86 and recall values are 94 and 53. If you plot the confusion matrix you will find that 1500 are correctly 1500 213 are correctly classified, and these are wrongly classified. And this is because of we are working with just 86% accuracy. And if we change the training of the model, definitely we will get a good results. So this is all about your neural network based model for customer churning of the bank. I hope you have understood these things. Do visit other videos also which are based on for practicals. Thank you.